Okay, welcome back, Math 10s. This is our final lesson. This is a challenging unit. We've been graphing a lot of lines. We're going to get one more form. This is truly a lesson in algebra techniques mostly. So we're going to be bringing back a lot of skills from Math 9 and a lot of the algebra that you've been doing thus far. So standard form. Recall, we have two other forms for lines. The first one, and it is honestly our favorite and the most commonly used one, is slope intercept. Okay, and slope intercept has the form y equals mx plus b. Okay, where m is our slope and b is our y-intercept. We also got a second one called slope point form. Now, just like its name suggests, we know the slope and we know a single point on the line. And it looks something like this: y minus y1 is equal to m, the slope, multiplied by x minus x1, where x1 and y1 is a point on the line. Now let's explore something called standard form. This is going to be really useful, especially in Unit 6, but we're going to learn how to use it here at the basics in 5.5. So standard form is a linear function, and it looks like this. We have ax plus by equals c. Now there's a couple really important things here. To put it in standard form, first, put a star here, order important. Okay, important. It has to be the x term plus the y term. Okay, sorry, it can be subtraction, but it has to be x term, y term equal to some constant c. Okay, also, no fractions or decimals. No fractions or decimals. Show some strategies on how to get rid of those. And always reduce. Kind of like finding a GCF in previous units. We always want to reduce. So if A, B, and C are divisible by 2, we'll divide them by 2. We'll reduce them. Couple other things here. A is a whole number and it must be positive. Whole numbers are positive by definition, so must be positive. Okay? And it can look like this. We can put C is equal to AX plus BY. That's perfectly okay. But we do want to keep this order. And it's kind of easy to always look at the first one because it's alphabetical. A, B, C, and X comes before Y. So it's a little bit easier. So B and C have to be integers. That's why it's saying no fractions or decimals. And A, B, C have no common factors other than 1. So that's the reduce part. Okay, so the order is important, no fractions or decimals, and reduce. So in other words, the leading coefficient A must be positive, okay? And there are no fractions or decimals. So really, I'm showing you, here it is. Here's one way to describe the rules, another way here, and then another way in the longer form sentence. Okay, so let's explore this new standard form and how to get it. So we can see here, we're going to work with a range of questions. This one, we want to write it in standard form. So first of all, we need to get the constant on one side, okay, and our x and y term on the other. So right now I see my x terms on the left, but my y terms on the other side. So I'm going to move that first. So I'm going to put up my fence here, is helpful when doing algebra, is I'm going to subtract 8y on both sides. Okay, that's going to move this from this side. And now I'm going to rewrite it as 2x subtract 8y is equal to negative 4. Now, at this point, we look like we're done. We say, yep, I have my x term and 2 is positive. I have my y term and it's equal to the constant. But remember, we have to check if we have to reduce. So we can reduce this. And the idea is that we can divide the entire thing by 2. Okay, 2, 8, and 4 are all divisible by 2. So we're going to rewrite our final answer to look like so. 2 divided by 2 is 1, so I just have x. 8 divided by 2 is 4, so I have minus 4y. And negative 4 divided by 2 is negative 2. And there we are. We have our standard form, which is reduced. There's no decimals or fractions. It's in the right order. I have a positive leading coefficient. All the rules are met. All right. We look at this one, and this looks like a slope-intercept form because it is. And so how do we take this and convert it to standard form? First, always, if you see any fractions, we're going to clear the fractions. Okay? And this is really easy. All you do is find the fraction, the denominator, and multiply everything by it. If there's more than one fraction, just multiply by the common denominator. So we're going to take this entire thing. So on both sides, we're going to multiply it by 3. And when we do that, when we go 3 times y, that's easy. We just get 3y. But when we multiply here, the 3 and this 3 will cancel. So I'm only left with the negative 2x. And 3 times the 4, of course, is plus 12. Excuse me. Okay, so now fractions are gone. Good. We need to get the x and y terms on the same side. So right now, just by looking at this, I could move the y term to the right, or I could move the x term to the left. Remember, I want my x term to be positive. So if I add 2x to both sides, it'll become positive. So that's going to be my strategy right here. So let's do that. We'll put up my fence. I'm going to add 2x to both sides. When I do this, this will cancel, and I'll have 2x. I will write that first because remember, order matters, plus 3y is equal to 12. Now take a look at this. Are we in standard form? I have a positive coefficient. Good. Are there decimals and fractions? No. Can I reduce it? No. There is no common divisor of 2, 3, and 12, so we know we have standard form. We're done. All right. Next, this looks like slope point form. So when we have slope point form, again, I'm going to suggest clearing fractions right off the bat. Don't multiply this in first. Let's clear the fractions. So we're going to multiply both sides by 5. Okay? We're multiplying both sides by 5. When we do that, this 5 is going to multiply in here. So I'm going to get 5y minus 5. And then here, this 5 is going to cancel with this 5. This is why I suggested this. We don't need to multiply this fraction in. We can just use this now to cancel those 5s. And now I'm just left with 3 times x plus 2. Now, some students think, well, don't you have to multiply the 5 into the brackets? I don't, because this is 3 over 5 is multiplying everything here. So this is a thing times a thing, and I'm just adding another multiplication. So I can cancel this 5 with this 5. Remember, multiplication, we can do in any order we want. So now we're going to distribute. We're going to multiply this 3 in. And let's see what we get. So when we do that, we get 5y minus 5 still on the left side. 3 times x gives me 3x, and 3 times 2 gives me 6. All right, so we're getting closer. I need my constants on one side. I have negative 5 and 6, and I need my x term and my y term on the same side. So once again, I see my 3x will stay positive if I leave it here. So I'm going to move the y term because I want my x term to stay positive. So let's move the y term. Subtract 5y, subtract 5y. Okay, on both sides. That's going to cancel off. I'm going to have negative 5 here now. I'm going to have 3x. I'm going to write the y term second, and then plus 6. Okay, we're almost there. Now I just need to get the 6 onto the other side. Get all my constants over, subtract 6 on both sides, and that's going to give me negative 11 is equal to 3x minus 5y. Now, again, we'll check our 3 things. My leading coefficient with my x is positive, positive 3. I have no decimals, also no fractions. There is no common divisor of 11, 3, and 5. So here is my standard form. Okay, and just remember, you could also write it as 3x minus 5y. Just put that on the left side is equal to negative 11. That is the same thing due to the equals sign. Equals goes left to right and right to left. Okay, we got some decimals to deal with here. That's okay. How could we get rid of them? We see that I have tenths. Okay, 1.8 is tenths and 1.25. So whenever you see decimals and you need to remove them, we're just going to multiply by 10 as many times as we need to, because every time we multiply by 10, it moves the decimal over. And I see I have to move this one over twice. So we're going to multiply both sides by 100. Okay, so we're going to multiply this side by 100 and this side by 100. Okay, so decimals are going to disappear in a second. 100 times y, well, that just gives me 100y. And when I take this 100 multiplied by 1.8, that moves the decimal over twice. You can try it in your calculator, and you're going to get 180x. And likewise, this decimal is going to move over twice, and I'm going to get 125. Okay, now that solves our fraction problem. And next, I need to get all my x's and y's on one side. So I see my x here is positive on this side. So again, I'm going to move my y to the other side. But I'm going to do two steps at once here because I think we can handle that. I'm going to subtract the 100y. So subtract 100. Sorry, I shouldn't write that right there. Let's be careful. Okay, I'm just going to write it over here because it's not a like term. Subtract 100y. And at the same time, I'm going to subtract the 125 to the other side because remember, I'm going to need that on the left side afterwards. So we can do two steps at once if we feel comfortable enough. This will cancel, and we can see clearly what's left over. Well, I'll just have the negative 125 on this on the left side. And then over here, I'll have 180x. That's canceled, so minus 100y. Okay, now we can see here we do have it in standard form, except, well, we've gotten rid of the decimals. Okay, we're in the right order. We have a positive x term, except obviously these three can be divided by 5, so let's do that. They can be reduced. And when we divide it by 5, we're going to get negative 25. 180 divided by 5 is 36x, and 100 divided by 5 is 20y. Again, take one last look. Can I reduce it any further? And the answer is no. There is no common divisor of 25, 36, and 20, so we know we have it in standard form. Okay, let's flip the page and let's do one more question. It's a two-parter. So we can graph equations in standard form, and the best way to do that is using a strategy we learned a while ago, is finding the x and y intercepts by substituting zeros. Or the other way is we can change that into our favorite, which is slope-intercept form. Okay, so let's give this a shot. Here we are in standard form. So first we're going to find the x and y intercepts. So recall, if I want to find the x-intercept, we have to substitute y equals 0, because to cross this x-axis, the y value must be 0. So let's do that in our equation. So it's going to be 3x minus 2 times 0 equals 18. Well, that's going to go to 0, so that's gone. So I'm going to be left with just 3x is equal to 18, and divide 3 on both sides. That's going to give me x is equal to 6. So our x-intercept is at positive 6, which is right here. Okay, in other words, when I put in a 6, I get a 0. So that was the coordinate we just achieved there for my x-intercept. So this is what we would call our x-intercept. Okay, now let's find, so that was the x-intercept. Let's find our y-intercept now. Now we do the exact opposite. We're simply going to substitute x equals 0, because wherever it crosses the y, the value must be 0. So we're going to put that in. So 3 times 0 minus 2y is equal to 18. Again, that's going to cancel out to 0, so I'm going to be left with negative 2y is equal to 18, and divide both sides by negative 2 is going to leave me with y is equal to negative 9. Therefore, when x is 0, y is negative 9, and this is our y-intercept. And as soon as we know our two intercepts, we can plot this line. So our other intercept here is at -9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 is right here. And we can plot our line. I'll try my best to keep that as straight as I can. It is so hard on this trackpad. But you can do a much better job than that. Okay, now how about transferring it into slope-intercept form? We haven't tried that yet. And remember, all we need to do is solve for y. So we want this, we want y is equal to mx plus b. Therefore, all we got to do is solve for y. Okay, so our equation is as follows. We have 3x minus 2y equals 18. So we want to solve for y, so let's get it isolated. Let's get rid of that 3x first. Again, throw up a fence. This can help with algebra and manipulating equations. We're going to subtract 3x on both sides. Okay, that's going to cancel here. I'm going to be left with -2y is equal to -3x. Put the x term first, plus the 18. Remember, these are not like terms. You cannot combine them. Okay, to say 18 minus 3 is 15. That's not true. They're not like terms. And finally, let's divide by -2 on both sides. So everything gets divided by -2. That's going to cancel out here. And that's going to leave me with just y is equal to double negative here. So we're going to write it as positive 3 over 2 is the slope times x. And positive 18 divided by -2 is -9 is our y-intercept. And so let's check, does this fall in the same location? So I'm going to use blue for this. -9 is our y-intercept. Yep, that's the same number we got right here. And our slope is 3 over 2. So up 3 over 2, up 3 over 2. You can see how badly my line is not perfect, but you can see I land perfectly on the x-axis where we planned. And so, yes, this is absolutely slope-intercept form for the exact same line. Okay, so coming back to in the very end of this, what did we do before I read this sentence? We learned about a new form. We have three total. We have slope intercept, slope point, and now standard form. Standard form looks like this. We have to meet these three requirements. They have to be in the right order. The x term must be positive, and they cannot be decimals or fractions. Okay. We need to reduce if possible. We had to do it here, and we had to do it here in D. So we had to reduce those so they're fully simplified as much as possible. Quick strategy on how to get rid of decimals is multiply them by 10 or 100 or 1,000, however many tens you have to multiply to get rid of those decimals. And then we finally were able to see, well, what we have to do to graph these things. Now we can see this form isn't as easy as the other two in graphing them right away. In slope intercept, we plot the intercept and use the slope, and we can graph really fast. No BEDMAS or algebra required. And with slope point, it was the same thing, just using a point instead of the y-intercept. But we noticed with this, we had to do all this extra work here, finding the x and y intercepts. You might think, well, why? Why are we learning about standard form? Well, it's coming up in the next unit in a big way. So why do we use it? Many word problems or real world problems very often translate into equations that happen to be in standard form. So we're going to be dealing with them a lot in our last unit 6 on graphing. So we'll see that in the next unit. For now, that's it for unit 5. We'll see you in class to dive into the practice.